Okay, so quick look at question 9 in 9C. So a couple put down $50,000 on a new home and arranges to pay off the rest in monthly payments of $1,384 over 30 years at a compound interest rate, compounding monthly, of 8.5%. All questions to the nearest cents, unless otherwise advised. Use rounded payment and balance values in subsequent calculations. So first off, what was the selling price of the house? Okay. So to work out the selling price of the house, we understand that they had $50,000 down payment over 30 years. So 30 times 12 at an interest rate of 8.5%. We're not sure of the present value. Okay. The payments we're told are $1,384 a month. The future value of that loan has to be 0, and both of these are 12. Right, so the present value has to be 100 and, sorry, I should have had a negative in front of the payments. That's what's come out like that. Negative, and we'll solve for that now. Okay, so present value, part A, oops, got a right highlighter. Part A is $179,994 and 24 cents plus the $50,000 down payment. So now we're looking at $229,994.24. Okay, so that's part A. So we have to take what the present value is. We found the present value based on the fact that we're paying that over 360 months at that rate. And that gives us a present value of that for what they had to loan based on the fact they had a deposit of $50,000. Okay, part B. We want to know how much interest will they pay over the term of the loan to the nearest dollar. Okay. Okay, so for part B, sorry, there's a long pause in the video, so if I you can pardon me if you want. So if I'm covering this again, it's because of the long pause in the video. So part B asks us how much interest will they pay. So there's a couple of ways to work this out. I think the easiest way is to do this. So here we're calculating the amount of the payment with an interest rate of 8.5%. Now we're told that we have to make these to the nearest cent for subsequent calculations. So I'm going to put that to 24. This I'm going to change to 0 because if we're paying 0% interest on this amount and we look at our new repayments, the difference will give us how much interest we're paying each month. So at the moment when it was 8.5%, we're paying $1,384. Our house cost that much. Now for 0%, if I solve for the payments, we get $499. Always do that. $499.984. Okay. Now, if they're the repayments without interest, and these are the repayments with interest, then the difference must be the interest that we're paying. So I'll just do that on my normal calculator. 1384 take 499.984. That gives me a value of 884.016 per month interest. Okay. Now if we times that by 360, the term of the loan, So we want to know how much interest they pay over the term. Then we get the total interest. And that comes to $318,245 and 76 cents. Okay, so that's part B. Okay, so part C, how much do they owe after 6 years? So 6 years of monthly repayments, we've got 6 times 12, which is going to give us 72 at 8.5%. That's the present value. Their payments are still $13.84, so that's their original payment. And better put a negative in there. So the future value of that is $169,798 and 795 cents. So we go 169,798 and 80 cents rounded. Okay, so that's part C. Fairly easy. Just change that to 6 years. Original interest rate, that's what the house is worth. And then we have the payments that they originally stated. Okay, over to part D. Now the key with part D is we're told this question cuts off. I haven't edited this perfectly. Right there. After 6 years, the interest rates increase by 0.9%. The couple must now extend the period of their loan in order to pay it back in full. Okay. How much will they still owe after the original 30-year period? Okay, so for that, we need to make some adjustments up here. So after 6 years, that $169,000 figure is now the present value. All right, we've done it for 6 years. So I'm going to get rid of that up there and copy this, pop it up there. Need to make a couple of adjustments. That negative is gone there, and we're told in the question to use rounded payments and balance values in subsequent calculations. So we're going to change that to our 80 cents. We're told that it goes up by 0.9%, so it is now at 9.4%. And payments stay the same. Future value we're not sure of. That's what we're going to solve for in a moment. We need to change N though. Okay, N in part D, I'll change that over here. N is going to be equal to 30 years take 6 years, which is 24 years. Okay, so after 24 years, or 24 years, and there's 12 payments every month, we want to know what the present value is. So 24 times 12. And we're going to solve for future value. Okay, so the outstanding amount after, where am I? There. After that time is $111,567.69. Or let's make it easy. $0.70 rounded. Okay. Part E. Calculate the new monthly payment amount required if the couple still wants to pay it off in the 30 years they originally wanted to. All right, so we know that they've gone through it for 6 years so far. So we're going to keep that value there in N. The interest rate here is going to stay the same. The present value is the same after 6 years. That hasn't changed. We're going to solve for the payment. We know that if they're going to pay it off after that total of whatever years, we're going to need future value to be 0. Okay, so the payments for this are going to be $1,487.29. Okay, that's rounded. So I hope that gives you a hand with question 9 in 9C. Any other problems? Let me know.